sklearnmetricsmeantweediedeviance. Description: explain in detail. The mean tweedie deviance is a metric used for evaluating the performance of tweedie regression models. It measures the average difference between the predicted and actual target values, taking into account the distribution of the target variable. Inputs: y true, the true target values. This is a 1D array of the actual values of the target variable. Y-pred, the predicted target values. This is a 1D array of the predicted values of the target variable. Power, the power parameter of the tweedie distribution. This parameter determines the shape of the distribution and can be set based on the specific type of target variable. Outputs: the mean tweedie deviance score. This score is a single value that represents the average difference between the predicted and actual values, weighted by the tweedie distribution. Steps: calculate the deviance for each individual data point based on the predicted and true values. Sum the deviances for all data points. Divide the sum by the number of data points to get the mean tweedie deviance. Metrics: mean tweedie deviance, the average difference between the predicted and actual values, taking into account the distribution of the target variable. Visualization plots. Residual plot: a plot that shows the difference between the predicted and actual values. This can help identify potential problems with the model, such as heteroscedasticity or nonlinearity. Fine-tune parameters. Power parameter. Power, the power parameter of the tweedie distribution. This parameter can be tuned to improve the performance of the model. Uncertainty methods. Confidence intervals. Calculate confidence intervals around the predicted values to quantify the uncertainty in the predictions. Bootstrapping. Use bootstrapping to generate multiple sets of predicted values and estimate the distribution of the mean tweedie deviance. Challenges and fixes. Challenge 1: incorrect power parameter selection. Sample use case that resulted in challenge 1 using a power parameter that is not appropriate for the data can lead to poor model performance and an inaccurate mean tweedie deviance score. For instance, using a power parameter of 1 for a target variable with a Poisson distribution will result in incorrect calculations. Fixes to challenge 1: carefully select the power parameter based on the distribution of the target variable. Use domain knowledge and exploratory data analysis to determine the appropriate power parameter. Challenge 2: data with outliers. Sample use case that resulted in challenge 2 outliers in the data can significantly affect the mean tweedie deviance score, as they contribute disproportionately to the overall deviance. Fixes to challenge 2: handle outliers by either removing them from the data, transforming them, or using robust regression techniques that are less sensitive to outliers.